I wanted to thank the both congressmen for the invitation to speak today. And really, I sort of want to start out, manufacturing a solution for our nation. And my kids, tell me this, said, well, Dad, punctuation can be critical. In fact, can be, life-saving. And the example they gave me was, let's eat, Grandma, and let's eat, Grandma. And I see it the same way here. Really, manufacturing a solution for our nation and manufacturing a solution for our nation. It goes both ways. If we look at it in terms of really getting it done, right? I mean, I think a lot of it centers on job growth and the economy, and I think Deborah hit on the head, national security. These things are critical in terms of moving it forward. At the pinnacle, I really see innovation. But I think that really you've got innovation, and then you really have to take a look at both the research side and the education side. How do you bring those together? And as Bob mentioned, I'm over at Georgia Tech, so again, you're getting a little bit of a faculty perspective, but I've spent some time in the government. I've done some startups with some of our technology and our students, and even dealt with companies over in the West Coast. We were acquired by startup groups over in the West Coast before the dot-com burst. Biggest lesson I learned was don't go for the stock options. So, but if you look at it, it really is exciting to sort of see what's going on and to work with these students who are so innovative, so forth, and really bringing it all together. But it is about applying the technology and moving it forward. In terms of some of the things that we really do need to think about in the United States, and I think Nick hit it right on the head. We are great at bringing ideas up, coming up with ideas and sort of getting them to benchtop. Then the question is, where do we go from there? I look up at the flat panel display, developed here in the United States. Where are they produced now? Certainly not here. My other favorite example is the VCR. Some of you might not even be old enough to have ever used a VCR, right? And my point there is technology comes and goes. And in fact, really, I think next generation, those flat panel displays are going to be replaced by flexible electronic displays. So your next, may I borrow your pen? Your next cell phone may look like this, where you just pull it out, okay? And by the way, when that happens, all of the infrastructure, all of the ecosystem, the supply chain that's over in the Pacific Rim, that is one of the reasons that we've heard you can't manufacture a mobile phone or a smartphone here in the United States, that all goes away, because once you start rolling them up on that flexible electronics, they start popping off. So all of a sudden the ecosystem changes. And by the way, it's not just technology, it's also about our workforce. And so we've already heard about that in terms of what's going on with our students. In fact, actually, I'd say let's just start passing around. Reese, could you pass around? What I'm going to pass around are just a couple of aluminum parts. So people talk about 3D printing, but we heard the good Professor Sue, who, by the way, was my undergraduate research advisor, talks about the NC machines. Those are machined. On machine tools, turbine blade machines. They were programmed by high school students with a gaming type interface using high performance computing that's readily available today, just available. So all of this is coming together. Question is how we're going to use it, right? So we've got our ecosystem coming together. We're coordinating it. We see what's going on in the United States. For example, the National Network for Manufacturing Innovation. And I think that was a brilliant move. We have other opportunities to move forward. I think what we really need here in the federal government is a very high level of coordination so that all of these different elements can be put together appropriately and really leveraged, and not just the government operations, but a lot of the new concepts moving forward. High performance computing is great. So in fact, if you have a chance, go look it up. The website's easy to remember, right? HPC4MFG, right? It's a great website over at Livermore. But there, we have people who are trying to figure out, all right, well, what should I be doing with this? I can tell you the mechanical engineering students at Georgia Tech, and I'm sure at a number of other universities, MIT, Notre Dame, are already starting to think about how we use high-performance computing. In fact, you see that Xbox camera right there at the bottom? That is something that a good chunk of our students have with their video games. That is a high-speed digitizing camera. So if you ever watched NCIS, and they're moving the screens around and stuff like that, this camera will do it. I have mechanical engineering students, undergraduates, juniors, okay, who are taking a system like that and just repurposing it and building their own inspection software for real-time inspection. Something that certainly 30 years ago was impossible, and even 10 or 15 years ago would have cost you millions of dollars. And this is what the kids are doing today, and it's basically just bringing things together. So research, development, education, and engagement is really important, but our raw material also is changing, and I think we need to understand that. So we have engineers today who think very differently. People say, well, they can't focus on a single thing. You know what? It's not clear to me. I was talking to a colleague of mine who did his PhD about 30 years ago, and he said he had to spend days just inking up drawings. Now, that's focus. But pretty much today, we're not inking up drawings. You know, they're drawing them up. They're just using their gaming technology to move it forward. So maybe we leverage that. Maybe we think a little bit differently. We think a little bit broader, and we make use of that type of capability. But I think a key thing, and the real strength of this country, really is moving new ideas to implementation. So again, back to Deborah's statement, it's really enabling innovation. How do we take those ideas and get them out there? And I think we can look at them from a very economic perspective and say, yeah, that's how you're going to make money, right? If you can't scale something up, can't scale a great design up, you cannot make a serious profit on it. But we can also look at it from a very altruistic perspective. The Salk polio vaccine is one of my favorites. If we couldn't scale it up to billions of copies in a cost-effective fashion, we couldn't have nearly eradicated and hopefully very soon eradicated polio. Right? So these are very important things to be thinking about. And again, the federal government here in the United States, and by the way, we see this around the globe, but what happens here in Washington, the decisions that happen here in Washington are being followed across the globe. And we are leading, and the rest of the world is following. So, in terms of the big picture, and I think Nick pointed it out, yeah, that's a KUKA Titan 1000 robot. You know, when I was over at BMW, we installed 320 of them. Did we lose some jobs? We lost some jobs that I don't think you would like to be doing. We got some new high-paying jobs, you know, supporting those robots, installing those robots, programming those robots. But that plant became so efficient that it generated 3,200 new jobs, because that's where you need to go. So you have to move forward. So the technology needs to move forward. We have a different workforce. We've got to leverage them. But let's not forget our current workforce. We're in the workforce for 50 years now. I'm an automotive guy. Think about the car from 1966. That's ancient technology. So we've got to keep our current workforce moving forward. We have to think about our leadership in terms of policy and make sure that they're well informed on technology. So forums like this are perfect, right? And I've seen, it's very heartening to talk to Congress, to talk to people over the executive branch, to the president and so forth, that they understand that technology is so important and manufacturing is so important to our nation and to the world. We've got to make sure that we can keep that innovation rolling and that our talent pipeline is secure. So education, again, back to education. And at all levels, I should say. But again, you see these parts going around. By the way, I need those parts back, otherwise the students don't get credit for their high school projects. So don't walk away with them. They're going to be upset with me. But again, this is, you know, at all levels we should be doing this, and we can do this. So in terms of the world, we're understanding what's going on in the present, and we're going to drive the future. In my opinion, in terms of at least our workforce, it's about lifelong learning, because you have to continue learning all of your life long. So I'll just close with a favorite comment from 20th century philosopher Eric Hoffer, and he said, and I think this is perfect today, in fact, at the rate of change of technology as it accelerates, it's even more important in the 21st century than it was in the 20th century. In times of change, learners inherit the earth, while the learned find themselves beautifully equipped to deal with a world that no longer exists. So thank you very much for your attention, and I'll be glad to answer questions after Professor Schmidt's talking.